in example 14 and part B, we are supposed to show that 3 sine x, the same question as part A, plus 4 cosine x can be written in terms of r cosine x minus alpha. And we know how we have started in part A. We have been able to express, because we know r cos x minus alpha. And when we say when it is cos, something a minus b, it is obviously followed by a plus, which is equals to, which we know this one to be equals to r cos x cos alpha plus r sin x sin alpha. That is true. And because we have been knowing that we are expected to express 3 sin x plus 4 cos x in terms of r cos x minus alpha, and the r cos x minus alpha itself is expressed this way, therefore it is right to say 3 sin x plus 4 cosine x is exactly equals to, or can be expressed in terms of, r cos x cos alpha plus r sin x sin alpha. So that if we look at the first, if we look at if you look at now the two expressions, or the expression or the equation, it has the left hand side, and of course it has the right hand side. So what are we saying? We are simply saying that the cosine of alpha, r cosine of alpha, is equals to 4. But let us compare the two, because the sin x appears here. If we say this 3 sin x is exactly equals to r sin x sin alpha, if we divided both sides by sin x and sin x, then we can easily say that r sin alpha is equals to 3. We can easily say that r sin alpha is equals to 3. Consequently, this one is going to be equals to the first term. Because why do we have to compare this with this? Because this one has cos x and this one has cos x. So there is a lot to cancel out. And that is also why we considered 3 sin x to be equals to r sin x sin alpha, because sin x appeared here and also here. They had a lot to cancel out. At the same time, we can already see that 4 cosine x is equals to r cos x cos alpha. Divide by cos x, divide by cos x. And that one gives us a situation whereby r cos alpha, this part now, to be equals to 4. And sure enough, we are told that, of course, we have known that every time we have a situation like this one, we know that the sine of x over the cosine of x is the tangent of x. That we know for sure. So at the end of the day, it is important for all of us to note that r sine alpha over r cosine alpha, which is equals to tan alpha, is simply 3 out of 4. That means there's an angle is equals to 3 over 4. There's an angle alpha whose tangent is 3 over 4. And if you move along with your calculator, you will realize that alpha, or rather shift tangent 0.75, is going to give you 36. Is going to give you 36.9 degrees. So easily, if that is true, then we can go back to the trigonometric triangle. If that is alpha, opposite over adjacent 3 over 4, but instead of writing these 3, we can have r sine alpha. Instead of writing the 4, we can have r cosine alpha. And of course, this is 5. But let's see. 3, and there's 90 degree there. Let's see. It's instead of just talking of something to do with r squared sine squared alpha plus r squared cosine squared alpha is equals to 3 squared plus 4 squared. That means r squared sine squared alpha plus cosine squared alpha inside the bracket will definitely give us 25. And if you look at this, this is obviously 1. R squared is 25, and r, this gives us r is the positive root of this, which is 5. So yes, we have been able to establish the value of r, and we have been able to establish the value of alpha. So at the end of the day, we can simply say that 3 sine x plus 4 cos x is exactly equals to r, which is 5, open bracket, the cosine of x minus 36.9 degrees. And that is just like it. So we have been able to show or to establish, and this is our final submission, hence shown. So example 14 is very important in both cases. Please know how to follow, and in case you have such a question, it is important to remember the original addition formula and how they can be expanded to give us what we have now. All right.